Welcome to Rges Pre-Algebra. This is Lesson 30A. We're going to be covering sections 8.22 through 8.25, all regarding the topic of area. We'll start with a psalm. This is Psalm 90, and it says, Lord, you have been our dwelling place in all generations. Before the mountains were brought forth, or ever you had formed the earth and the world, from everlasting to everlasting, you are God. You return man to dust, and say, Return, O children of man. For 1,000 years in your sight are but as yesterday, when it is past, or as a watch in the night. You sweep them away as with a flood. They are like a dream. Like grass that is renewed in the morning it flourishes and is renewed, and in the evening it fades and withers. For we are brought to an end by your anger, by your wrath we are dismayed. You have set our iniquities before you, our secret sins in the light of your presence. For all our days pass away under your wrath. We bring our years to an end like a sigh. The years of our life are 70, or even by reason of strength, 80. Yet their span is but toil and trouble. They are soon gone, and we fly away. Who considers the power of your anger and your wrath according to the fear of you? So teach us to number our days, that we may get a heart of wisdom. Return, O Lord, how long? Have pity on your servants. Satisfy us in the morning with your steadfast love, that we may rejoice and be glad all our days. Make us glad for as many days as you have afflicted us, and for as many days as we have seen evil. Let your work be shown to your servants, and your glorious power to their children. Let the favor of the Lord our God be upon us, and establish the works of our hands upon us. Yes, establish the works of our hands. Well, this is a tremendous psalm, and there's many, many beautiful truths in it that we can hold on to and be comforted by. But I would say probably the overarching idea here would be found in verse 2. From everlasting to everlasting, you are God. So in my mind, what he goes on to describe, some of the things, is that we are frail, that we are temporary, transitory. Our lives flash by, even like the grass that's here today and is gone tomorrow. That we live our lives before the sight of a holy God. It says, our iniquities are before you, our secret sins are in the light of your presence, that he is the one we answer to. It says our days, all our days pass away under your wrath. So we are accountable, we're answerable to God. And even if we manage to live a long time, the large percentage or a great part of our lives are spent in toil and trouble. In other words, this world is full of many trials. Okay. So that's one focus. The first focus is us. We are frail, we are needy, we are sinful, we often do what is wrong, what offends a holy God, even what offends others. Even many times what offends ourselves. Right? These kinds of ideas. We are needy. It seems to me the second thing that's focused on here is that much of our neediness, if not all of our neediness, but he enumerates many things that we need that God provides. For one thing, we see that he provides, how do I want to say this, entrance or access to his presence. He says, you have set our iniquities before us. That's our accountability. But our secret sins are in the light of your presence. Now, yes, he sees them, but they're also before him. We stand before him. So there is an access that we have. He says, teach us to number our days that we may apply our hearts to wisdom. Wisdom comes from God. It says love, gladness, joy. Especially look at this last section. Healing, power, your favor, Lord. You establish the work of our hands. Healing, blessing, power, loving kindness, strength, all these things that we have need of, he provides. And the third main point I would like to make, there's many other things you can draw from this, but going back to the very beginning of the psalm, he says, before the mountains were brought forth, or ever, you had formed the earth and the world. From everlasting to everlasting, you are God. He says at the very beginning, verse 1, Lord, you have been our dwelling place in all generations. So not only are we needy, not only does he provide what we need, but he is always there for us. He is always what we need. He is unshakable, unshakably all we need. And there's great comfort. We shake. We go up and down. We're strong, then we're weak. We're confident, then we're doubters. All these things. We shake a lot. But God himself never shakes. He is from everlasting to everlasting. So we put our confidence not in us, but in him. So I don't know about you, but I am very, very grateful that that is the God that I serve. And he makes up for all that I lack as I learn to lean into him, be confident in his work. It says, show us. Show your work to your servants and your glorious power to their children. And so we ask the Lord to open our eyes that we might see him in his goodness, his mercy, his grace, his forgiveness, his power, and his steadiness. Open our eyes to see you, Lord, that we may see you, that our children may see you, that we might declare your mighty works from generation to generation, for truly you are worthy. Amen. So make sure you go get your homework and your book also. We might be using that. And we'll be looking at 8.20 and 8.21, which were the homework assignments you had last time, discussing perimeter and circumference. Now, perimeter is the distance around a polygon. Remember, a polygon is going to be a two-dimensional shape made up of line segments. Whoops. How about, let's try to get that a little bit different there. Okay. And it's a simple closed figure here. And so to take the distance around, we would start at any point. We would start at a vertex, and we would count the distance. Whatever this distance is, plus this distance, plus this distance, plus this distance, plus this distance. And that would be the perimeter. Circumference is the perimeter or the distance around a circle. So I've written these answers in here after our review on perimeter and circumference. And recall that perimeter is the measure of a polygon, is the measure of all the sides around. Whatever this side is, I said A plus B plus C plus D plus E. Circumference is going to be, recall the ancient Greeks discovered this, And they did it by stretching a string across the diameter, starting at that point and cutting that string, pulling it across to this side, again, and it always came up with the same ratio, no matter how big or small, 3 and a little bit more. That little bit more is 3.14. And that is, we call that special number pi. This is the Greek symbol for p. Okay, so that's pi. Okay. So the circumference is pi times the diameter, or because diameter is also 2 times the radius, it's pi times 2r. Pi times 2r. But we want to want to put numbers first and variables last. This is a constant because it never changes value, but we'll put the actual numbers first. So as we reorder it, we'll get 2 pi r. So these are two things you want to memorize. Circumference equals pi times d, or circumference equals 2 pi r. Okay. Now, when we go then to our homework on 8.20, 1 through 9 all, the first three are find the perimeters of the drawings. The first one is it happens to be a parallelogram, but we're just going to start at one point, start in one corner, one vertex, and add up the numbers all the way around, and we should get 34 feet. The second one is an octagon. It has 8. It's a regular octagon, meaning all the sides have the equal length, and they're each 4 feet. So if we take 8 times 4, we would get 32 feet. And the last one appears to be a square, as all the sides are equal. And so we'll take 4 times 7.1, or 28.4 feet. Now in the next 6 problems, the last 6 problems, it says use a formula. So for each of these, I start with the formula. Okay, number 4. It's a rectangle, so my formula would be 2 times the length plus 2 times the width. Filling in the numbers, multiplying each by 2, adding them together, I should get, for number 4, this isn't 4.62, but for problem number 4, this is 62 feet. For problem 5, my formula should be 4 times the length of the side. 4 times 9 will be 36 inches. Number 6, a triangle, you add up the 3 sides, and you're going to get 21 inches. Number 7, you have a square. The perimeter of a square is 4 times the side, 4 times 4.2, and that's going to be 16.8 feet. For number 8, the rectangle, start with the formula, plug in. Now, the longer of the two is always going to be considered the length, so we plug in the 11 with the L, and then 9.5 for the width. 2 times 11 is 22, 2 times 9 is 18, and 2 times 9.5 would be 19. Add those together and you're going to get 41 inches. And finally, another square. It's 2 2/3 is the length of each side, so you would want to go ahead and change this to improper. I consider this probably the easiest way for students. There's more than one way to do it, but we're going to change that to an improper. 3 times 2 is 6, plus 2 more is 8/3, and then 4 times 8/3 is going to be 32/3. Changing it back to a mixed, 3 goes into 32 10 times, and 2 left over. So it would be 10 2/3 inches. Now let's look on the next page for circumference problems. For number 1 through 3, it says find the circumference when you're given the diameter. So we're going to use circumference equals pi times diameter. Recall that pi is 3.14. So for number 1, if the diameter is 4, I would say C equals pi times D. C equals pi is 3.14. D is 4 feet. Multiplying it out, 12.56 feet. all three problems are done the exact same way. Number 2, your answer should be 18.84 inches. Work them all out just as I did number 1, putting your formula first, substituting, doing everything nice and in order. Okay, 18.84 inches should be your answer. Number 3, you've got 3.5 yards, and you're going to multiply that out. You're going to have 2 decimals, but you know how to do that. And your answer, if we knock off the trailing 0, will be 10.99 yards. Sorry, my pencil's not working. There we go. All right, for the next group, we have radius is what is given. So for number 4, we'll work together. It's asking what would the circumference be if the radius is 7 inches. I start with my formula, 2 pi r. I plug in for pi, and I plug in or substitute for radius values. So c equals 2 times 3.14, and radius is 7 inches. Multiplying all that together, we're going to get 43.96 inches. For number 5, we'll do it just the very same way, and you'll get 40.82 inches. For number 6, little different now because we have a fraction. So I'll start with my formula, 2 times, it's given a radius, so 2 pi r, plug in for pi, plug in for r, you're going to get c equals 2 times 3.14, radius is 2 1/2 feet. Whoops, I don't need to put the feet there, okay? Now, we could multiply these two and then multiply by 2.5. That would be perfectly fine. I could say 2. Here's another way you could do it. I could say 2 times 2 1/2 is 5, and multiply 5 times 3.14. I think I like that because I could do that in my head, and your answer is going to be 15.70. And your units are feet. I think the only one I would comment on in this group is number 7. It says 3 1/4. Well, we could change this to a mix, or to an improper fraction, but because we're already multiplying by 3.14, I would be inclined to change this to another decimal, 3.25. Then either do it longhand or do it on a calculator. All right, so that's the answers you've had before. Now we want to move into the new idea, or that's the homework you had. We want to move into a new concept, and that is area. Now, area is the region inside a figure, a two-dimensional figure. So let's say I have a rectangle that's 3 by 5. That's a little long, 5, but that's all right. I decided I didn't want to draw so many squares. And I wanted to know what is the area inside, or what's the region? How much does this shaded, what's the amount of shaded region? It's hard to come up with another word other than area. What's the amount of shaded region that is covered inside of this whole area? Okay. Well, if I were to draw 3 1-inch squares in this direction and 5, a little bit poorly drawn, but sorry, in that direction, how many 1-inch blocks, if this was 3 inches here and 5 inches here, how many little 1-inch blocks would I have? Well, there's one, there's one, and I'm sure you've worked with area since you've been very young. Well, I would have 5 in the first row, 5 in the second row, 5 in the third row, or altogether 5 times 3, or 15 1-inch blocks. So to indicate 1-inch blocks, I would say square inches. That means a little square, 1 inch on each side. 1 inch by 1 inch. I could also say 15 square inches, just like that. Okay. And sometimes you'll see it, though he tends to write it this way, 15 inches squared. We haven't really introduced too much about exponent yet. I think you've had some. Yeah, you've had some about exponents, so we could do it that way. All right? So that's area. Now the area of a rectangle would be found by multiplying, just like we just did, the 5 times 3. So the area of a rectangle is length times width. So if I told you I have a rectangle that's 9 feet by 12 feet, the area would be 9 times 12, or 108 square feet. If I'm talking about the area of a square, so area of a rectangle was 1. What if I had a square that was 5 feet on a side? Well, what do you think I'd do? Well, if it was 5 feet, the length would be 5 and the width would be 5. I could look at it that way. It's a special kind of rectangle. Or I would just say 5 squared. The area equals the side squared. So there's a formula, and there's a formula. So for this one, the area would be equal 5 squared. That means, remember, 5 times 5, or 25 square feet, or square inches, whatever it would be. Let's go to the next one. Could you figure out, now that we're going back now to 8.22, I wanted to do this in a little different order. If we're talking about 1 square foot, we're talking about a square that's 1 foot on each side. How many square inches will that be? Well, the way I figure that out is how many inches are on this side. Well, 1 foot is 12 inches. How many inches are on this side? 1 foot is 12 inches. And now, so how many square inches would there be? 12 times 12, or 144. And so that's what that unit's talking about. Again, if I had a box that was 1 square yard in all, okay, that would be 1 yard here, 1 yard here, and I want to know how many square feet is it. Well, how many feet are on this side? 3. How many feet are on this side? 3. And 3 times 3 is 9 square feet. See how that works? Okay, so I'll leave the rest of that to you. We can talk about it if we have any trouble, but I think you'll be all right with that. Now, if we're going, maybe I'll just do one more. Okay, what if I went from inches, or square feet, here we go. There's a square foot, has I have 18 feet here and 18 feet here. Okay, so I didn't mean a square foot. Okay, it said, I'm looking at number 6. It says, how many square yards do I have if I have 18 square feet? So 18 square feet means a box that's 18 feet on each side. We'll convert this to yards. How many feet are in a yard? I'm sorry. If I have 18 feet, how many yards is that? I would divide by 3, because there are 3 feet in every yard. And so I'd have 6 yards here, 6 yards here, and 6 times 6 is 36. So now we've gone back and forth between larger units, square yards, to square feet, okay, to smaller units, and smaller units to larger units. So you should be in good shape for that, and your homework is going to be okay, this looks like more homework than it is, so don't panic. This has to do with area of rectangles, very simple. This has to do with areas of squares. Okay. This is a review, and a lot of these are just true and false, that kind of thing, very quick. And this is going to be that last little idea of converting measurements. Okay, so did several of those already for you. You should be in great shape. Have a wonderful couple of days, and keep plugging forward. We're not that far from the end of school. God bless you all.